So yes, it's my great pleasure to chair this first panel of today, entitled Does Connected Data Need AI or AI Need Connected Data? Admittedly, the AI bandwagon is riding fast and loud these days, and it remains in the spotlight of many communities, computer science, tech industry, enterprise, and whether we like it or not, also popular media. So it's very tempting for any new aspiring technology to claim strong links to artificial intelligence. Connected data is certainly one of those concepts that is commonly associated with AI. It's kind of grown out of AI research, and it claims it also can solve many problems in the AI space. So in this panel, we'll try to discuss and reflect on the nature and the extent of this relationship. And I think well, you've seen most of the talks already in the morning, so you know the panelists, but let me just quickly go through the names again. We have Spiros Kotoulas from IBM Research Ireland. We have Tara Rafat, a chief ontologist and associate vice president at Emphasis. We have Freddy Lecuy, a principal scientist and a research manager in artificial intelligence systems at Accenture Labs, and Paul Groth, disruptive technology director at Elsevier. So let's start. I've wanted to introduce you a bit deeper, but then I thought, okay, maybe you're the best qualified actually to tell in a few sentences how do you work with connected data, and what does it mean for you in your space?
I'll start. You just saw it.
That's easy.
Ready?
Yeah. It's on. You just need to speak. Okay. It's on?
Yeah. Okay. So, well, I mean, so as I mentioned, Accenture is a service company, so we don't really have any products. We build solutions for clients, and we try to bring different AI solutions. I mean, depending on their needs. And they heard about buzzwords on AI. So when they think about AI, they think about deep learning. I mean, that's basically the shortcut they're using. And they try to apply the hype and new technologies. So before we say, well, that's the right thing you need to apply, we try to figure out what the problem they have. And sometimes very basic and simple models for doing predictions or whatever the problem they have might just work. And sometimes connected data it's not the approach that you need to bring. So it's really depending on the problem they have and the data issue they have. And those companies, they just heard about those news from Google, from IBM and large companies about the big data problem that they have. They do have big data problems. They have large amount of data. Amazon is another example. But those companies, they usually don't have. They don't have everything digitalized. They don't have large amount of data in general. So they have a big small data problems. The way we name it. So sometimes you need to enrich the data they have with more data to contextualize information. And in large number of cases, we try to understand what I mean. We really start from the data. What's the data they have, and then how we can achieve the goal they want. And in some cases, we bring this connected data or knowledge graph or external data that push much more context to the information that they have. And sometimes the information that they have internally is not enough for doing the goal or the work they want to do. So that's where we bring connected data. So again, it's not each and every problem that will need it, but sometimes, like the work I presented, you need external data. You need to bring much more contextual information. And Paul and Spiros, they mention it to some extent in their work they're doing. They bring external information together. And that's the way we're doing. We have the same philosophy. We try to bring in knowledge graph or semantics if that's needed. I mean, we don't want to overkill the problem.
Yeah, thanks, Freddy. No, that's fine.
Okay, hi everyone. So I work for a company called Emphasis, which is also a services company. So we build solutions, but we also have products as well, which is built on semantic technologies. Their foundation models are ontologies. And I actually want to mention a different aspect of when talking to customers. So a lot of them, yes, as Fred mentioned, they have heard the word AI and they come over and say like, oh, build us an AI solution. I want machine learning. I want deep learning. But a lot of them have actually a different approach. So we talk to them and say, hey, look, we've got connected data, we've got semantics that makes your data intelligent, we've got some AI working on it to give you recommendations. And they're like, well, wait a second, AI? I mean, we're not there. We're not yet there. This is scary. Elon Musk said it's going to kill us. So it's just like really, really like the other way around. So it's their approach is like, no, we don't want AI right now. And for us, like for me, I've had a lot of actually webinars talking to people who are not in this field, because we're dealing with businesses like finance, insurance. So they're really not in the AI field itself, but they're hearing about this technology and it's freaking them out. So what I try to do is actually really break down what AI means, because this word is really being overused. And I'm sure all of you have like different definitions of it, but it's really nice to kind of break it down into what are the fields of AI, what are the subdivisions, and then go back to like what Freddie said, is like which one of those can actually be useful in a sense to solve your problem, and also to make people kind of understand that they're actually dealing with AI every single day, every minute. All of you have your iPhones. I hope you have Google Pixel though, but you are dealing with Siri. You are talking to your Amazon Echo. You're using Google Home. So everyone is just using it. Do you use Google Now to plan your trip? That's a lot of AI that's happening, a lot of natural language processing going through your emails, extracting where you're going, like planning your trip for you, saying like take this bus to go to the airport to get there on time. So all of this that you're dealing with every day is actually a part of artificial intelligence. So getting people to know that, and customers, they're like, oh, okay. And then we can actually extract exactly the same technologies and apply it to fields that is relevant to them, like their business, their finance or insurance or manufacturing or anything that they're interested in. So I just wanted to bring that aspect of it out as well, to see the other side of the spectrum.
Thanks, Tara.
Yeah, sure.
In IBM research, in our research group, what we're mostly dealing with is healthcare and social care solutions for large organizations. They can be governments or other types of large organizations. So this is not the environment where you're going to change a database. Right? These databases have been there for a long time, or sometimes they're not even it's not even a state-of-the-art databases. There would be legacy systems, but any kind of change can take years. Right? So the data integration part that comes together with linked data, I don't see it happening yet, just to be honest. The second part, and where I do see linked data having an immediate impact, is when we're combining it with something else. And I can give you a specific example where we're using linked data. So as I mentioned earlier, most of the cases that we have to deal with is people with significant and complicated needs. And to understand these significant and complicated needs, many times you need to train a recommender model, a machine learning model, and so on. The problem that you have with this kind of approaches is that sometimes the results that you get can be very wrong. And if something is very wrong, for example, if somebody is treating a female patient and you say, yeah, check them for prostate cancer, it is not just that, okay, this is a stupid recommendation, don't do it. It is also that people lose faith in the system. Knowledge graph, actually, and we are using this in practice, can help you clean up your unreasonable recommendations or your unreasonable predictions. Right? And of course, to do this, you need to be able to connect data. In healthcare, for example, it is data, I would say it's inherently connected because you have so many different terminologies that are being used, so much existing knowledge. I think Paul, during his talk, also mentioned that there are so many approaches to try to extract knowledge out of unstructured documents, that it's really an area where connection is there, but at the same time you want at the same time prediction is there as well.
Thanks. Tara, you mentioned in a moment ago that a lot of effort in your work you have to put into clarifying some overloaded concepts, right? And I was thinking, since we are all kind of ontologists, maybe we could dare to come up with a concise definition for each of you in your work. How do you define for yourself what connected data really is in a kind of compact way? What is it? Is it this or that data format? Is it a whole philosophy of connecting data points? What is it really? What is this conference about, really? That's the question.
Well, I think the first thing that comes to mind whenever you say connected data is being able to extract information from different sources and bring it together. So this is literally like what Paul was talking about, of showing all these different variable sources that you have that have different formats of data. I think I lost this. Okay, now it's working. So that have different formats of data, and you really want to have as much information as possible when you're going through the process of decision making. So linked data in that sense, in the very easy sense, means that I can bring all of this information from these different sources to integrate them together. And the problem that usually exists is the interoperation problem between these different sources, because they all follow different schemas, people use different vocabularies. So that's another layer of thing for me to the linked data concept in general. Because yes, you bring the data in from these sources, but what if people have used different terminologies? How do I actually connect them together to get that whole view of the data? And that's where that abstract level of the knowledge graph model comes in. That's where you're defining what are the different concepts, how they're related together. So how can I fit this data that I'm bringing in together into this knowledge model so it actually make sense? So for me and in my work, that's really like building that abstract level and trying to bring information from all these different sources to connect them together in a format that's understandable by the computer, and therefore I can do a lot of more intelligent stuff with it, automate a lot of things that are happening in the industry today. So that's kind of what really linked data kind of means to me in my work. So I stop you for...
If I can follow up with a question to the rest of the panelists, how is this different from data integration?
So I think this is the real...
Can you take the mic?
I'm on a mic.
You're on the mic.
I have a mic. I have my own mic. Yeah. No, I mean, I think this is really a fundamental thing, is like, I think the parts of it is that you have the data integration, but you as an organization, especially from an organizational perspective, you need that same conceptual view of the world across at least parts of your organization. So it's very much, if you want to be really old school about it, it's like creating an enterprise data model. That's like a really old school way of thinking about that, but with the flexibility of being able to adapt that enterprise data model over time to source the concepts coming from the enterprise data model from different places, combined with the importance of data, right, in that process of that data integration. So that's, I think it's just two old school technologies, right? We can call it enterprise data models plus data integration on steroids. How about that?
Shall we compare revenues of enterprise data warehouses with linked data technologies?
Okay, let's link back for a moment to artificial intelligence, as this is we're trying to understand this relationship. So there are two sides of this question, of course, and let's start with one of them. In what way AI systems, and in what sense AI systems need connected data? Where does it come in really useful? So you mentioned now building this one big conceptual view over the, say, infrastructures involving AI systems. Yeah, that's going to be one point here. In what other sense does connected data contribute to AI?
For me, it's reduction of cost. If I'm using linked data, and that goes back to the previous discussion, but not intentionally, if I'm using linked data, I get some of the integration for free. If I'm using a linked data format, for example, to describe a patient, right? I can just pull in Freebase or Wikidata or whatever, and I just get additional information practically for free. And this, for me, this is the essence of the value of linked data. Reducing cost. Of course, I could make an enterprise data warehouse and integrate this data. Would be not a problem doing that, but it would just take me more time.
Yeah.
I actually want to touch upon the integration point as well that you mentioned, and then that is, it's actually a layer of intelligence that you're adding as opposed to just old school data integration, because one very interesting thing that we hear from our customers usually when we work with them and say like, okay, you want to work with this amount of data, we're going to pull it from different sources. The question is like, how are you different from exactly data integration systems? And my answer is that I'm not going to overload you with data, because it is really important to pull out the relevant information for you and just bring that to the screen for you to observe. Because if I'm going to overload you with data and just say, okay, I've integrated everything for you, then there's a problem. Like, I'm not really helping you, I'm just making you more confused. So that top level of abstraction, of conceptual models that go on the top are really to help with this intelligent extraction and integration of data. That's what it's helping. And coming back to your question in terms of how is that helping, I think that was a great point in terms of the cost, obviously, because what we hear from a lot of people is that the cost of making good data to feed into the machine learning algorithms is really high. So if you have cleaned open linked data to feed into it, that's great. But there's also another aspect, and that is when you could use knowledge models to kind of guide the right data, which is very similar to what you mentioned of coming up with recommendations which are completely irrelevant. So your results from a machine learning algorithm is as good as your data is. So if your data has problems, your results will have problems. And unfortunately, currently a lot of data sets that exist, they're facts, but not necessarily complete and comprehensive facts. And can I give an example, which is a little bit, so let's say you want to hire people. So you have a machine algorithm that's trying to figure out whom you want to hire, right? So you're feeding a lot of resumes and data into it, and you're feeding a lot of information about the very successful CEOs. So you want to hire a CEO for your company. So obviously, the first thing that the algorithm would look and learn is that, okay, out of this 5,000 that you gave me, 4,000 were men, 1,000 were women. So the first point is that the one that I'm going to select is going to be a man, right? And then looking at those mans is like, the men is like, okay, 80% of the successful ones were white, 20% were minority or color. So I'm gonna select a white man. So then they go through the CVs of people, and these are the first two filters that the algorithm will do based on this data. So how do we avoid things like that? Is that you really need to have something that's actually kind of semi-supervised learning process where you could use a knowledge base in the back to give you information about what is the discrimination going on in the workplace right now? What is the rate of people in terms of like education 10 years ago as opposed to now? So you get those information from other sources. So this linked data here could actually provide you with all the extra information that you could feed into your system to help the learning process to be a little bit more accurate.
Okay. So the process becomes more accurate. So can we, for instance, can we improve machine learning? Can we find something more and better if we use linked data? Can we maybe explain the results? You've been talking, Freddie, about explainable AI. Can we explain the results better, communicate the results better of machine learning using connected data methods? Is there where also the value lies?
Yeah, I think this is where one of the value is how you can use this linked data, or this, I mean, we use also the term context. So you contextualize the domain, and some enterprise have internal data about the enterprise. They know what's the policy and the legacy internally, but externally they have a lot of information they don't have access to, and how you bring it back, and you can help contextualize any decision you're taking, and explain, help system being self-explainable somehow. So we really try to expand the data with more context to give much more evidence to people on what the data that you have might mean in a much broader context.
So I want to push back here a little bit. I think, so I actually think linked data or this kind of connected data is actually useful for people, right? Machines think in large, ginormous matrices, right? What do you feed to machine? You feed feature vectors, right? And I don't think for most development of new models, linked data really gives you much. And in fact, it's something I've been struggling with, is to communicate this connection that we've been talking about a lot. What I can say is that the results of models, our recommendations, our predictive models, those have to be tied to something. And that's really where we've seen the benefit of having, connected data, is that we can really we can tie a recommendation directly for a person, and we know that that's a person, and it's one person. We can tie, a chemical directly to, we know it's this thing, right? And it's helpful for people to consume. I'm playing devil's advocate here. I think there's obviously some benefit to having more data, right? But why don't we just learn from our data lake, right? Because we got one of those too, right? Why don't we just learn from the data there? Why do we need to go to this effort of data integration at all for building our AI models? That's what we've been talking about a lot internally, is we understand the value of connected data for our developers, our end users, for people. It's less clear to me that it's actually valuable for straight up building kind of machine learned models.
So, I got your point. If you take existing very simple machine learning systems and you're training on some of the data that you have, let's say you start with decision trees, the first rules with the highest confidence and accurate are things that everybody knows. It's kind of common sense knowledge. And they're still on the top because they are very high confidence, high support, and but the people don't care about those particular ones. So that's where you can use linked data or common sense knowledge that you can capture from somewhere else and prune those particular rules that doesn't really make much more sense. I mean, that makes sense, but that you don't really need. And to go back to the Spiro's point when he say, well, you do predictions and you want to also prune the one that actually have inconsistent meaning. And he said that sometimes they learn wrong things, and then how you discard the systems to learn those wrong things. So I think this is where the context or external information might bring you some idea on some techniques to prune the search space and
But if you're doing an end-to-end deep learning model, you have an end task in mind, you have some input data, isn't that the fundamental revolution, right? Is that you have feature detectors that are being built automatically. You don't have to organize the data for the machine, it organizes itself, right? So why do we need to organize it beforehand?
Well, it works very nicely for some applications, video processing, natural language processing, but others, they just fail because they don't have the large amount of data that the deep learning approach needs. So deep learning might work in some cases, it had revolutionary impact on some applications, but in others, you need something else.
Okay, yeah, let's keep this thread open for a moment. Maybe some ideas from the other side, or?
Yeah, so just to add to this, I agree with Paul that it is not a fundamental revolution within its algorithm. Again, from a cost proposition, the way that I see this working, I can give you an example in the healthcare domain. You have your, let's say, some huge hierarchy of terms. ICD-10 is pretty large, right? My data just doesn't cover all of those. Right, they just don't appear. What do I do? Okay, I can generalize. And that, with connected data, is very easy to do. Right, and if you're thinking of a hierarchy, I'm not saying that you should go and do that. You can move everything up one level in the hierarchy, and suddenly you have one order of magnitude more dense data.
So you're saying it's fundamentally the grouping capability of the models that we typically develop, the taxonomy models, is kind of fundamental for aggregating enough data so that you can do the training.
As one use case, yeah.
Yeah.
Okay, so I would like to slowly start opening the floor for questions from audience, but before that, okay, let's quickly jump on the other side of this issue and think for a moment, in what sense connected data needs AI? So we've been talking about these knowledge graphs, and of course, we cannot expect everything will be curated manually and built manually, so definitely linked data needs AI also to grow. Can you elaborate on this? Do you have any views on this problem?
I think Paul really touched upon this in his talk really clearly of how it could be used in I helped building the knowledge graph. And just from an ontologist's perspective, I'll tell you that it's a really hard job to build these knowledge models and ontologies. It's really a way of thinking and a way of like trying to get access to the knowledge that exists in people's heads or like in books, or so it's just like so much information, and you want to bring all that together and capture as much as you can to create a model that is really reusable, and it could solve your problems, and you can apply algorithms to it and axioms to it. So it's a really complicated process, and that's why it takes like years to build that medical ontology model, or it's not an overnight thing. So anything that could help to even semi-automate this process, it's needed. And I think the whole NLP, machine learning, data extraction is definitely need for human intervention to look at the models, make sure everything is correct, but a perfect first step and start.
Okay. I think one thing I didn't mention, and I think it's really important here, is one of the reasons that we cannot find, we have limited number, we have domain experts, and we need to optimize their time. And we also, people who do connected data, right? So finding ontologists is it's a hard problem, right? To hire good ones is really difficult. So we want to optimize their level of effort, so then they're not just kind of sitting there curating data. We want them designing the upper level models. We want them to make sure that the systems are designed appropriately. So I think we fundamentally have to have intelligence in order to just optimize our workforce correctly.
Okay, do we have any questions from the audience, please?
First of all, thanks, panel. A lot of healthy debate there. Unfortunately, I'm old enough to actually remember AI before the last AI winter, which was roughly, mid-90s through the early noughties. I attended a few conferences like that, maybe late 80s, early 90s, and we talked about connected data. We talked about semantic networks. We talked about machine learning. So I would like to throw open to the panel, what has fundamentally changed since then and now?
Yeah, thank you.
I can give a quick answer from my perspective. I think two things have changed. One is the availability of data, and the second thing is the computational power. So these two combined together is what's making all this visions more possible today. So AI at some point was if you can have an expert system. That was AI for people at that time. Right now, expert system is just like very basic, linear first order logic. And AI for people right now is to think about autonomous cars or flying machines, So the idea and the definition has completely changed, and what has empowered that is really the amount of data that's available and the computational power that has increased so much.
Yeah, I would just say examples of effectiveness in real world applications. I mean, and that makes it so much easier for organizations to really believe, right? And once you have belief, you can do a lot more. But we just see it day to day, right? So it's really hard to get around AI, right? My phone is going to get delivered tomorrow with facial recognition built in, right?
If it works, let's see. Right?
Maybe to add to this regarding connected data and AI, there has, maybe I missed it, but there has been no connected data revolution. there has been a connected data evolution. And this goes back to what Tara has mentioned. So yeah, we have more data and we have more computational power. So will we in the next 5 years and the 5 years after that and the 5 years after that? These are things that have evolved. In my opinion, nothing has fundamentally changed.
Yeah, I agree with the panel, and yeah, also impact of some success stories. So I believe so. Yeah, I agree. Won't really have nothing to add.
Yeah, thanks. Any other questions?
Any questions on this side of the room?
Hi. So this is not so much about a question, but about like food for thought. To try to understand what are the gaps we really have as a community to work on with building these connections with AI and other big data technologies, etc., for example. And those connectors, I think it's not only from a conceptual perspective, how those technologies work together, but also like from a practicality of things, how we basically create tools to enable other communities, like the AI community, to come and work together with us. So, yeah, I just wanted to mention that.
Okay.
I did want to mention something. So I think for us, in terms of that, is we've seen that the move around the big data space has really also helped us begin our story around having a connected data space, and it's helped us drive development around AI. And the particular practical application of this is that we have a data lake. It's up in the cloud, right? We have an environment we use that's based on Spark. It's called Databricks, that all of our data scientists can go and they can start seeing all the data available for them to play with. That's great, that's cool. They start training algorithms. They start saying, what the heck does this column mean? And then we have these big long discussions on our data science mailing list, somebody trying to figure out a particular Parquet file, right? And then what we're saying, well, this is a benefit to us internally to start having common definitions of key attributes on our data. Where should that be? We should have an ontology for that. We should have vocabularies around that. So in some sense, that trend has opened the eyes of at least that community within our organization to the need for better documentation and real definitions around important attributes and entities within the company. So that's really something where I think you end up coming to connected data whether you like it or not, maybe.
The question, why would you not use a database to maintain all these glossaries, definitions, and so on? For example, why would you use linked data technologies as opposed to adding an additional table to your data warehouse and saying, okay, this column means that column means that, and so on?
Could do, and I still would call that connected data, right? I think the point is starting having those definitions is a key part of what you would advocate if you're an ontologist, right?
So connected data is, what you're saying is more about, again, a philosophy of connecting these pieces of information rather than this or that data structure format, right?
Yeah, I mean, I have this rant that I go on all the time is that we start developers in our organization on teaching them about like linked data or this notions of knowledge graphs. And then what ends up happening is that developers want to perform another triple store evaluation, or they go off the deep end reading too much about OWL. And that's okay, it's great that they're interested in this stuff, but it's, the point is that it's more the conceptual framework and choosing the right tools for the right job. And somehow that's kind of the stuff, that kind of communication material, that kind of education material is really lacking, especially when you look at more, I guess, the semantic web style stuff that's out there, at least that I've seen. And so if anybody wants to correct me, I'm happy to be corrected.
But you were mentioning tools, so at the end of the day, if it's practicality and you want to implement, you have to choose a tool. So ontologies and concepts and relationships at a high level and abstract level, and what we mean is, yes, it's super interesting and we talk about it and it's like from the philosophy perspective, but really when you want to use that notion and coming to linked data and you want to implement it, it boils down to the tools.
Yeah,
so
but you can
what
pick
is
and choose the
of course,
ones you want, right?
Yeah, you can pick and choose, but you really have to understand what each tool is capable of in terms of, you know, and then there's a lot of discussion in terms of like why database as opposed to like why ontologies as opposed to databases. And one of the major like answers is the maintenance of an ontology. When your data grows, when new concepts come in, the redesigning of a database is way more complicated than just adding some concepts and relationships in a graph model that you have. So that would be, I'm sorry, I'm an ontologist, I have to kind of defend the ontology.
No, and I mean,
like,
what I would say is like we use like for ontology maintenance, we're all in on SCOS and OWL. Great. For some of our stuff, graph databases are great. For a lot of our stuff, I want a linked data API using JSON LD, right? And I don't want to mess with .NET, right? And they have like...
Again, you're talking about JSON LD, which is another thing grown out of the semantic concepts and annotations. So
the message is keep calm, keep connecting.
Yeah.
I guess. Okay, I think
that's a really good introduction to some of this afternoon's debates and panel sessions on, you know, the different standards and interface approaches and so on. I realise we're eating into people's lunch, if you'll excuse the pun. Big thanks to Shimon of Semantic Integration for facilitating and the panellists for
thanks for
really
the panel.
thought-provoking debate.
The audience.